they want us to graph this quadratic, and the best way to do this, there's no need to complete the square or anything like that. You could rewrite it if you want by just putting x minus 0 squared plus 1, and then you can see that 0 comma 1 is your vertex.
Mm-hmm.
You could do that if you wanted to.
Okay.
And then this 1/4 just means that it's compressed. It's compressed vertically. So instead of going up 1 over 1, well, here's how I like to think of graphing a quadratic. Your basic quadratic starts at 0, 0, and you go over 1, up 1, over 2, up 4, because it's a quadratic, over 3, up 9, because it's a quadratic.
Mm-hmm.
But if you put a 1/4 in front of it, it's going to go over 1, up 1 times 1/4, so it's flattening it out. Let me do a different color. Over 1, up 1/4. Over 2, up 1/4 of 4, which would be 1. Over 3, up 1/4 of 3 squared, which is 9. 1/4 of that is 2 and a little bit more than 2.
Okay.
So what it's doing is it's squashing it down.
Mm-hmm.
Still the same shape, but it's not like the original shape, which was a quadratic, which was just the normal width of a quadratic. So that's what putting a 1/4 in front of it does. So what's the graph look like? It's shifted. This one is also shifted up 1. So it's going to start here, and it's going to do that thing that I just told you. It's going to have that slightly more rounded shape than the original one was.
Okay.
And that's your graph. Now, are there any x-intercepts?
No.
There are none. Obviously, there are none. But when you're looking at this original equation to check if there are any, you plug 0 in for y. Well, really what you do is you graph it and you see there aren't any x-intercepts like we just did. But if you tried to find x-intercepts, you would solve. When you're solving that, you would get -4 equals x squared, and you can't take the square root of a -4. You can if you use imaginary numbers, but you can't for real numbers. So there are no x-intercepts. There are imaginary roots, though. So they may have asked you to also label the imaginary roots, in which case your imaginary roots would be plus or minus 2i, because the square root of 4 is 2, the square root of -1 is I.
Okay.
So if they ask you for imaginary roots or complex roots, then you do have to finish that problem.